All right, let's get started. Thank you everybody for joining us. I am Michael Locke. I am Automation Systems Manager working with the Precision360 team. I am so excited today to speak with you all with our very first Lunch and Learn series. And the topic today is automation. If at any point there's questions, feel free to send them to us or reach out. I'll be happy to answer those. So without further ado, let's get started. So for today, what are the discussions that we're going to hit on today? First, automation. Should you consider it? The short answer is yes, by the way. And I hope all the topics we talk about, that'll be clear. Small shop automation. What the heck does that mean? We're going to touch on that. Volume, low volume, high volume. We talk about the mixes. Why is that important to understand the work coming into your shop? Collaborative robots, cobots versus conventional robots. You've probably heard a lot of those buzz phrases in the magazines or the videos that you've seen. Let's talk about that. Standard versus custom automation solutions. There's a whole spectrum of the systems that you can look at for your shop and tailor making it for the parts that you see. We're going to look at what's out there in the market. Implementation, actual solutions like we have here today with our RoboJob system, and then the pitfalls of automation. A lot of juicy topics and a lot to go over, so let's dive in. Before we get started too much here, IMTS, did anybody go to IMTS? And if not, do you get plugged in with the local trade shows or even watch the YouTube videos online? Something that I saw that was really interesting about IMTS this year, usually automation at IMTS is all about the crazy things you can do with the robot. Overhead robots, robots picking up crazy heavy things, robots that can move the fastest. We didn't see much of that this year. We actually saw at IMTS very practical examples of automation. We call that standard automation, and we'll define that a little bit more later. But we saw these practical examples of automation, and it's showing this trend that I've certainly seen the last several months and honestly last couple years regarding what people are caring about, what kind of automation people want to see in their shop. That's the kind of examples we saw at IMTS. So there's this shift going on of what kind of automation is prevalent in the industry. So let's talk about, should you consider automation? The first topic here is spindle utilization. How many of you have hated when you've walked the shop floor and you see a machine sitting idle? Might not be anybody's fault. You know, maybe an operator's working on another machine, swapping out a broken tool, or addressing chip problems, emptying the chip bin. Whatever the reason is, we hate seeing a machine go idle. Maybe the machine's been running all day and you're leaving it, you know, first shift's over and, you know, 5 o'clock hit and you're walking out the door. Man, wouldn't it be great to get some more runtime on that spindle after 5? If you've had these thoughts, maybe you should be considering automation. And then kind of piggybacking off of that, labor. Oh my gosh, you hear about the skills gap, the labor shortages. I wonder how many of you have had some pain points with having labor that is consistent, just trying to find people. Maybe you need to grow your team. You have an awesome team already. You just can't find people to run your machines. That sounds like you. Let's talk automation. Lastly, justifying the cost of automation. You know, you have robots, bar feeders, these seemingly complex systems. They're a little pricey. We're going to talk a little bit more in this presentation about breaking down the cost of automation and maybe making it be right for you and your shop. A lot of great conversation points here. Increasing the output. Man, if I could tell you that the machines could run through lunch, let's talk 1 hour a day, 5 days a week, 5 hours a week. Is that pretty cool to get that amount of runtime back? Just the lunchtime hours for having your machines run. What if they could run a couple hours after 5 o'clock? Is that important to you? Would that make a difference? Automation's a one-time purchase. You're not going through and trying to hire people, putting the job postings on the job boards and interviewing people. You could have automation here next week if you wanted to. And this last question here, should it be difficult or easy to justify? I think if you do your job right, you consider everything in the presentation today, I think if you find a lot of the things that we're talking about, it should be pretty easy to justify. That's a decision you get to make, though. So what makes automation so good for small shops? There's two things that I hear time and time again. Two just needs coming out of shops who might be job shops. They have the high mix, low volume. Mike, the automation, it's got to be flexible. I have no idea what's coming through the door next week. The robot's got to be able to hit those parts and be able to run them. Okay, I hear that. And cool, the robot can run those parts, but it's got to be quick to change over. I can't spend more than a day getting the robot set up and running the next job. Quite frankly, I can't spend more than an hour getting the automation system changed over to run the part. So these are two avenues or two things that I hear time and time again. The robot and the automation has to be flexible, and it's got to be fast to change over. We see other things too, but man, these are like the top two things where automation could really make sense in a job shop environment. This topic's really good. Are you ready to automate? I love talking to the shops where they've had a job for months. They've had jobs for years. And they say, Mike, I know that job inside and out. Man, I can cut that part with my eyes closed. Again, we've cut hundreds, we cut thousands of them. It's actually really funny. When you start talking automation and you have a job that's seemingly so easy, I like to challenge people. The next time that job comes up, take a step back and just watch. When your operator, whoever is running the machine, does anything other than take the finished part out of the machine, put in the raw part, and hit cycle start, and you can walk away. That is the foundation of an awesome automation project. But make a note, though, anytime you got to pick up the blow-off gun and blow off the bird's nest or blow off the pile of chips, anytime you got to empty the chip bin, anytime you got to top off your coolant, anytime you got to make an offset, anytime you need to change out an insert, these are all things that will stop the automation, which is expected to some extent. But if it's happening time and time again and you're expecting that robot to run for hours and hours and a cutting tool breaks every 10 parts, we got to have that conversation, and maybe we got to make a more reliable process for the automation to be successful. So when you talk about are you ready to automate, a robust cutting process is the foundation for a successful automation project. And we're talking about operator intervention. I don't want an operator or whoever is running the machine to need to touch it. Take out the finished part, load the raw part, walk away. That is an awesome example of a project where automation would shine. Taking it one step further, you got to understand your parts. The raw stock type. What's the shape? I got round slugs. I got hex. What's the size? Diameter, length. How much does it weigh? Am I working with a pre-machined part? Am I working with a casting? All questions that are easy. You know the answers to that. But can we strategically put all the parts on paper and figure out, oh, okay, well, I have 10 jobs, 3 of them use the same style or size of stock, maybe we group those together. So we're trying to be strategic and really understand what's coming through the door and what can be thrown at automation. Furthermore, we understand what's going into the machine, what's coming out of the machine. Finished part geometry is critical. We're cutting these beautiful parts on these CNC machines. You could have something that looks beautiful or funky coming out. The robot's got to be able to handle it. The automation has to be able to handle it. So having a solid understanding of what the finished part looks like will also make sure that the automation runs successfully and can run the parts. Lastly, how many different parts do you want to run? Say if you got 10 different parts this week or this month. Depending on the complexity, maybe one is just a science project of a part. So having that discussion up front, hey, this automation solution that you're looking into, it can run 8 out of 10 of your parts. It can run 5 out of 10 of your parts. Is that okay? What's the ROI? What's the intersection point that makes sense for you? All things that we look at when trying to justify automation and make it make sense for you. Running lights out. This has been, man, such a huge buzzword. Has anybody heard it? Lights out manufacturing. Do you know what it means? Do you have your own definition? So that's the first thing. What does it mean to you? Everybody seemingly has their own definition of what it means to run lights out. So some big questions here. How much unattended runtime? Do you want to give material to the automation and have it run one shift, 8 hours, overnight, 12 hours, a whole day without touching it, 24 hours? What's that time that you're looking for? How many parts does that mean need to be queued up? If you're looking for a whole shift of unattended runtime, is that 50 parts, 100 parts, 200 parts? What's your cycle time? Realistically, if you have cycle times of 5 minutes, 10 minutes, you're going to have to queue up a lot of parts, or maybe not as many parts, to make it whatever length of time you're trying to run. So this is all about managing expectations. People love the automation, and man, can it kick butt with running all night long, but understanding cycle times in your process, how long things can, realistically run. The machine tool, do you need to change inserts after 20 parts? All things to manage the expectation of how long the robot can run. I'll tell you what, they have the capability to run all night long, no question. It's going to come back down to a robust cutting process, that foundation that I talked about in an earlier slide of understanding your parts and understanding the process. Man, the last one, chips and coolant management. This just seems to bite people, and it's that thing that you really got to pay attention to. People can cut 5 parts in a row, no problem. 10 parts in a row, no problem. The automation, it's going to keep making parts. So when you have whatever your batch is in the morning, can the robot, or can especially the machine tool, handle running that many parts overnight? You're going to have a mountain of chips waiting for you in the morning, and the robot, couldn't load the machine because the machine alarmed out. Whatever it is, having an understanding of your process is so key, which will then allow you to hit those numbers of running lights out. Automation for high mix or low mix. Let me take the automation out of the equation for right now. How might you tackle setting up your CNC machine for the high mix, low volume? Are you going to use quick change tooling, quick change work holding? Are you using collet chucks to be able to get to the next job faster, reduce your changeover time? When it comes to automation, the robot's no different than a CNC machine in that regard. I just have a tool in the toolbox. You got to be able to know how to apply the tool. What kind of accessories are you throwing on the machine to make your life easier? So when I'm looking at the robotics and the automation, I'm talking about the grippers. Do I have adjustable gripper fingers that can handle a wide range of diameter of parts? The table, can I queue up different sizes of parts on the robot table and have it be easy to change over so I can run 1-inch stock in the morning and 6-inch stock in the afternoon? So the automation and the robots that we're seeing here today have those kind of cues that you might see on the CNC machine. Quick change fingers, flexible part tables for quick changeovers. That's the name of the game to get you up and running faster when the next job hits and you got to get the next part running. Last but not least, I can't wait to show you guys this when we get over to the robot demo. Programming. You do not need a robot expert on your staff. You do not need to teach the robot, go to this point, go to this point, go to this point. Something really cool about the robot that I'm going to show you here today is how simple the programming is. You almost can call it conversational programming. You give the robot the data about the job, diameter, length, load the main spindle, unload the sub spindle, and the robot creates that recipe. And from there, I'm not even joking, the robot will know what to do and is able to be run. So we're going to see that a little bit later, but the software and standard automation is so juicy, it's the secret sauce. So we'll see that a little bit later, and I want to pay close attention to that at that point. Collaborative versus conventional robots. So collaborative, you might have heard the term cobots. So what is a conventional robot? What's a collaborative robot? So the robot we're going to see here today is a conventional robot. You see the yellow painted Fanuc robots everywhere. They've been in the industry for what, 40 years? That's the type of robot that could knock you on your butt because it doesn't know it's going to hit you. So traditionally, you see these big fencing and guarding, encapsulating the robot with signs saying "stay away." Cobots, on the other hand, you've probably seen the videos, read the industry magazines or whatnot. Cobots are the safest thing in the world, aren't they? And then we all proceed with the joke, well, if I put a knife on the robot, it's not so safe, ain't it? Well, it's all about the application. So let me start with this. Both robot technologies, absolutely fantastic. There's a time and place for them, and it's on a project basis. So when we work with somebody like yourself, a shop like yourself, we're going to look at your project. We're going to try to make the best product recommendation based off your parts and your process, and maybe you fall in the cobot bucket. Maybe you fall in the conventional robot bucket. Any which way, though, the solutions that you'll see here today and the robots that we're talking about abide by the safety standard people. So you see ANSI RIA 15.06. We're talking about systems that are designed around the safety standards. And going back, both technologies are great. We're going to look at your parts and your process to make an accurate recommendation of what's going to work well in your shop. So the big thing in here is, Mike, heck, which one do I think about? Which one do I put my effort towards thinking about that I should see in my shop? Honestly, they're both great. Let me just put that out there, and let's walk with you to figure out which one's right for you. Standard automation versus custom automation. The big thing I want to start with here, I want to highlight the spectrum. On one end, you have standard automation, and let's define that. Standard automation is pre-engineered and pre-built solutions. So the partners that we work with, and even some of our in-house robots that we've designed, we're designing under a set of specifications. You know, we're assuming a diameter range, we're assuming a length range, we're assuming the robots can handle up to a certain amount of payload. So when you talk standard automation, they've already been designed, which has benefits of low cost, fast delivery. We'll talk about the bullet points here in a second. So you have standard automation on one side, and then you have custom automation on the other. The picture I have here is an overhead robot. It's all guarded. The thing is so fast. It was purpose built for that exact part family, which is the beautiful thing about custom automation. It was designed for your parts. So that's the other side of the spectrum. Looking at the bullet points here, let's talk at a high level. Again, standard automation, pre-engineered solutions. So with that, it's less costly. Everything has been already engineered up front. So that cost savings, that package is passed on to you. Because everything's already designed and engineered, delivery times are so much shorter to the point where systems are even in stock. And then there's a lot of benefits that I just mentioned. On the other side, it might not be as flexible. I might not be able to run all 10 out of 10 of your parts that you're going to see in a week or a month. So keep that in mind. But on the custom side, it's purpose-built for your project, your process, your parts. It's going to come at a hefty price tag and a long delivery, but if you have requirements that you need the automation to handle all of your parts, then let's talk custom. So that's on the other side of the spectrum. Automation implementation thoughts. So this is my very secret 4-step plan on how to be successful with an automation project. I wish it was that simple, but I highlight a lot of key ideas here, very important ideas that I want to hit on. So first and foremost, step one, before you even think about which automation, which robot to bring in-house, you got to have a robot champion, somebody that's going to understand and own the product, not to the level of knowing how to program the thing, but that's going to own it and be able to run it and be able to fully embrace it in the shop here. You can't bring a robot in and just expect it to work and look at the team saying, hey, you got this, right? There needs to be a plan. You need to designate someone to be your champion to own the automation. And what we're trying to avoid there is something that I hate to see. It breaks my heart. Seeing robots in the corner gathering dust. And I can only think that the poor shop that bought that robot with so much excitement about utilizing and embracing automation, they probably didn't have somebody, that robot champion, that was going to own it and see it through. So first and foremost, identify your robot champion. Step number 2, you got to pick a good robot partner. So we haven't even thought about the robot just yet, but when I talk about a good automation partner, I'm talking like the Precision360 crew here. Somebody that knows the product, the CNC machines, and the automation and how to get them to work so well together. I can tell you with step number 2, it is not about watching YouTube videos and understanding how to program a robot. That's not what I'm talking about. Again, if you have that focus, you're going to see a robot in a corner gathering dust, I hate to say. The secret sauce of finding a good partner to walk with on your automation journey is, how does the robot toggle the chucks? It's not going to press the foot pedal, I'll tell you that. How does the robot cycle start? How does the robot know when the cycle's complete and you hit M30? That nitty-gritty details is what's called a robot interface, but you need a good partner that has the machine tool knowledge and the automation knowledge and can get it to work well together. So you got to have a good automation partner to walk with you. Step number 3, you got to pick your project wisely. I'm such a big fan of the crawl, walk, run kind of methodology of approaching automation adoption in the shop. You can automate the whole shop if you wanted to. Robots taking parts, they're inspecting it, they're blowing it off, they're laser marking it, you're sending offsets automatically back to the machine. If that's your first automation project, it's a big project to swallow. Start by crawling. Pick a project that you know will be a home run. And a project like that I'm talking about literally, when you go back to understanding your parts and understanding your process, try to think of a part or a part family where you truly know that part process inside and out. Chips aren't building up. Tool life isn't a problem. Operators aren't having to do wear offsets constantly. You can truly take out the finished part, put the raw part in, and walk away. That's the kind of home run of a project where step number 3, pick your project wisely, that's what I'm talking about. So crawl, walk, and run, especially if this is your first automation project. Last but not least, you got to outfit your machine. Like I was kind of alluding to, the robot's got to know how to handshake with the machine on a bit level. How's it going to exchange those I/O signals for the robot to tell the machine to open and close the chuck and so on? So similarly, kind of piggybacking off of having a good automation partner, your machine tool is going to need things like an auto door, a robot interface. Do you consider a chip conveyor, high pressure coolant, probing, a mist collector? The list goes on, but again, we're trying to build a reliable process where that robot can truly run through the night or however many hours that your process will allow based on the cycle time. So the last step here, your machine's got to be ready for automation. So a lot of big thoughts here. Let's talk about solutions. So this is actually the products we're going to talk about. Here for the seminar, we're talking about fixed headstock Tsugami lathes and then Tsugami Swiss lathes. What are the products that we can put on that? So the RoboJob on the left there, that's a product that we're going to have a demo here in just a second. And actually, it's already here. So let's pause the presentation here, and we're going to take a field trip over to the RoboJob, and I'm going to show you some things that make that automation really special. All right, so let's look at the demo that we have prepared for you. Before we get too far into it, what equipment do we have here in front of us? So for the CNC machine, we have a Tsugami M08SY horizontal lathe. So that's a main spindle, sub-spindle machine with a 12-station turret, Y-axis milling on the turret. This CNC machine has also been prepped for automation. So you'll see at the top, we have an auto door. So the robot's not grabbing the door handle and opening and closing it. We have a dedicated actuator to open and close the door. You also can't see this option, but behind the scenes, we have what's called a robot interface. So we talked about in the presentation not too long ago, the robot's going to be able to tell the machine to open and close the chucks. Cycle start. Robot's got to know when the cycle is complete. So we have all the I/O mapping on this machine to be able to handshake with the robot. So that's the CNC machine. Now for the robot, we have a RoboJob Turn Assist Mini. So this is the model of robot that works directly with lathes, and we're handling circular parts. And in that, we're going to do kind of a walkthrough to see all the special things, especially on the robot, that make it flexible, that easy changeover. I'm standing out here to start because one thing I wanted to note, you may notice the floor tape on the ground. So something you don't see is safety fencing guarding this whole robot. So this is a conventional industrial robot. If that thing hits you, it'd knock you on your butt. But the cool thing is here, we're using collaborative technologies. So something that's about at the ankle level, close to the robot, is what's called a safety scanner. It's actually looking at the floor, watching whoever is walking by the robot and determining if the person walking is too close to the robot. So the floor tape that we have here is actually strategically laid out to have it be a wide open robot where you don't need crazy guarding. So the first zone is a slow zone. Robot's going to slow down. The second zone, the robot's going to pause. And then if I walk away, the robot auto resumes. And then the third zone, close to the CNC, is the stop zone. So if I were to walk into zone 3, close to the machine, the robot's going to need to be reset simply to be told, hey, continue the job. It's assuming, hey, Mike, did you take a part out of the machine? Did you change an insert? Did something happen where you might not want me to run? So we're going to start to look at the robot here, but I wanted to make note of the layout of the robot and what you're seeing here and why the floor tape is here and what all this means. So that's the CNC, that's the robot model, and this is the layout and why everything is here. So let's start to talk about the robot system. So there's two big things that make it really important for automation when it comes to small shop, job shop automation. I got to have a flexible system that can handle a wide range of parts, and I need quick changeover. So before I get into the software, let's talk about the little things, the physical items on the robot that accomplish flexibility and ease of changeover. So first thing I'm going to mention, the dual grippers on the robot. So this is almost like a 3-jaw chuck. I'm going to be holding cylindrical parts with the robot. I have a dedicated gripper for my raw stock, loading the part. Then I have a dedicated gripper for handling the parts coming out of the machine. I cut the parts, they probably got smaller, so because I have a size difference of raw part going in and finished part coming out, I have a dedicated gripper for each instance. When it comes to changeover, the robot gripper fingers are kind of like your 3-jaw chuck on your machine. If you're moving the jaws, you're moving them on the serrations. The robot gripper fingers on the RoboJob work the exact same way. So based upon the diameter of my part, all I do is simply loosen the finger, move them down the serration to the designated position, and now I've changed over the robot to run the new size of part that I've changed over with. So the end-of-arm tooling, while it's a couple of robot grippers, it's actually very well engineered and intentionally designed for that flexibility and easy changeover. The next thing I want to talk about is the table. How am I going to store parts? How are my parts being presented to the robot? All this table is a simple grid plate. There's a bunch of holes in the table, and it works off of these pins. Now, these pins are set in the table in designated locations, and the software tells me that. That's a really cool feature that we'll go off of in a second. So once I build my table, I load up my raw stock, and then as long as I set up the recipe on the robot's going to do all the calculations of where the parts exist. I don't need to teach any of these positions. I'm no robot programmer. The robot has all the calculations and predetermined pick and place points built in based off the data you give it. So while the table is pretty simple at face value, there's a lot of flexibility here in changing over to small diameter parts, keeping the pins close. Maybe I have a larger part and I'm going to spread out the pins. I can easily accommodate a wide range of part diameters on the table. Depending on your part length, I might also be able to stack parts. So now you talk about taking a amount of parts that's 1 layer deep on the table, and depending on part height, maybe I can get a 2nd layer. I just doubled the amount of parts that are on the table, which is pretty cool. Questions like that is what we'll work with you on if you present a project to us, and we'll figure out what will make sense, how many parts we can run, what the staging will look like, and so on. Now, other than that, that's, I hate to say it, as simple as it gets, which is honestly really cool. This isn't meant to be a complicated system. You have your robot, you have your grippers, you have your part presentation table, and it's kind of that simple, which is really cool. It does not need to be complex. What brings it all together is the software, the HMI. So where I wanted to end on, because this is kind of the big thing I wanted to highlight, is how easy and intuitive the RoboJob software is. Now, looking at it, there's 4 main menus at the top. So I'm going to start left to right. I'm on my start menu right here. Say you have a job that you had last month or last week or even earlier in the day. I can save my part recipe, my robot routine, in my job management screen, and I can call it later. So say if I know that part's coming again next month, I can save the data and automatically run it and call it to make the changeover that much faster if I have a part that's going to be coming back and reoccurring. So that's the start menu, is my job data. When I go to the next menu, configure, this is where I start to get into part information. I'm going to tell the robot what's the diameter of my part, what's the length of my part. I'm also going to give it information on the finished part. I have a CNC machine. I probably took material off the part. It got smaller, so I got to communicate that to the robot to let it know what it's grabbing onto. And all that data going back to the physical world, based off of where the robots live on the table and where the finished parts get placed, the robot's doing all these calculations on the back end using the data that I give it to be successful here in real life. Again, not making me the robot expert and programming actual robot points. The robot has all the programming built in, which is fantastic. So after I look at configure, I gave it part information, raw stock dimensions, finished part dimensions. The menu that I'm on here now, I'm now going to tell the robot how to process the part. All right, robot, I want to use both spindles in my machine. This job is going to require the part to go into the main. I'm going to cut it in an op-10 fashion. I'm going to do a sub-spindle transfer. So robot, when the door opens, the finished part is going to be on the sub side. So here I'm telling the robot, load the main, unload the sub. I'm also giving it information about my chuck jaws. I probably machined the chuck jaws to have a step in it. I need something for the part to get thrown into and locate in Z. So I'm also communicating things like my jaw depth here in this menu. Another hidden screen here that actually has a lot of power. This is my program screen. What actual G-code program is associated with the job here on the table? Program 1000, program 2005, whatever the number is that you use, I actually can tell the robot, hey, call the right job on the CNC, and also we have this home program built in too. So at the end of the cutting program, you don't need to worry about having all your axis home positions at the end of the program. We actually have a dedicated program that we save on the control, so at the end, you're done your cutting program, the robot will tell the machine to home, all the axes are exactly where they need to be, and the robot can enter in and service the machine. On the next menu, I'm on the position screen. This is where we're doing a lot of interference checks. So you'll actually see a really cool graphic on the screen that illustrates the part, the gripper fingers, and actually the pins on the table. So the robot is kind of confirming with me, hey Mike, how do you want me to pick up the part? Are there any interferences? Do I need to have the robot come in at a different position, at a different angle to make sure everything works for this job? Another cool graphic that it's going to have you confirm, hey Mike, here's the part, the robot gripper fingers, and here's a graphic of the chuck. Now, when I place the part into the chuck, again, interference checks. Is everything going to jive where do I need to orient my spindle or orient my robot gripper fingers so there's no collisions, there's no interferences? The robot is doing all of this in the background, so you don't have to think about it. As long as you look at the graphic and you say, yeah, no, everything looks great. Let's keep moving on. I see no problems. Same thing on the finished part side. We're looking at the finished part coming out of the work holding. We're checking for interferences and if we need to have different lead-ins or orientations to make the job work for the robot. And then lastly, how is the finished part going to go back on the table? When I take a part off the table, part 1 is going to always reside in pocket 1. So finished part 1 is going to go back in the pocket that the raw part originated from. It's simple as that. Lastly, the last screen, automate. Now the robot's actually telling me, hey Mike, based off the part dimensions you gave us, mainly diameter, I want you to build the grid plate exactly to the spec here. So you'll notice all the blue dots on the graphic here. The software actually said, okay, great, I did the calculation. This is how you're going to maximize the amount of parts on the table. It's trying to get the most bang for your buck to have the best part density on the table. So the robot here is telling me, hey, Mike, don't think about anything. Build the table exactly like this. You're going to get the most out of your process. And then after that, the robot's going to also prompt me, okay, based off your part diameter, let's adjust the fingers. So there's designations on the fingers that are just random numbers per se. They're not meaningful to you and I, but there's a whole recipe in the software based off of part diameter. Am I grabbing the part OD? Am I grabbing the part ID? And the robot is actually telling me, hey, Mike, set the fingers to the 11 position on the load gripper. And then it's walking me through. Again, there's no decision making here. The robot and the software is coming up with everything, which is beautiful. I can follow along with the software. It's guiding me through the whole process. And we're talking about quick changeover here. I'm going to back up and look at the parts on the table here. So if I go into a detailed layout, I can actually tell the robot, hey, I didn't fill up the whole table with raw stock here. We actually had a bunch of demo parts that we cut prior to the show here to showcase the machining capability of the CNC. So the whole first row is occupied. So I've actually designated that in the robot software saying, hey, ignore the front row of parts for this sake at least, because it's consumed with demo parts for the show here. Say if you didn't have a full table of stock, you know, you could fit 40 parts on the table, but you only had 30 slugs to process. You'll actually tell the robot, hey, these are the 30 slugs in these positions, and the robot will be aware of that because you communicated how the table's built based off the information it told you. And now if I did my job right, I should be able to confirm any errors on the robot, and the main error that we'll see is I stepped in front of the CNC machine. I stepped in zone 3, which triggered the robot to say, hey, Mike, am I good to run? So right now, it looks like the speed overrides are reduced. So I'm going to turn this up to 100% of the speed that this cell is designed for, and we're going to pick the first part. this job was already pre-programmed, but nonetheless, it's not easy to walk through the menus and to follow along with the recipe that the HMI wants you to build, and now we're off running the part. So right now, the auto door did its first close, which is a little slow, and the robot just told the machine, hey, home the axes. I'm not sure where things left off. Make sure the sub-spindle is where it needs to be, and the turret's parked where I want it to be. So now, the robot's going to go in and load the part. But first, we programmed a jaw cleaning. So there's an air blow nozzle on the end of arm tool, and we're just trying to get rid of any chips that may have been on the jaws. The robot lets go of the part before the chuck clamps. There's a spring plate that pushes the part and establishes my Z location. It's almost like taking the palm of your hand and pushing the part into the work holding and then stepping on the foot pedal, and then the chuck takes over. The robot tries not to influence how the part sits in the work holding in a similar fashion. So how the robot interacts with the machine, it's very intentional and well thought out. So we had a simple dwell program on the machine to simulate cutting, and then the machine ran its home program again. Again, you don't need to have your axis reference positions, your G&M codes at the end of your cutting program. The robot's going to execute the dedicated home program at the end of the cutting cycle. So we cut our first part. The robot's going to go in, retrieve the part. Because we took the finished part out, maybe there was a small chance chips got behind the part and on the chuck jaws. Let's blow out the chuck jaws. And let's load raw part number 2. Robot's going to back out. The auto door is going to close. The robot will place finished part number 1 back in pocket 1. And now we're working on the cutting program for part number 2. So looking at standard automation to wrap up the demo here, there's not a lot of thinking. I don't need to be a robot expert. I hope that came through with how simple the robot system is physically, and then the software. You go through the 4 menus, you give the part job information to the robot, diameter, length, what spindles you want to service, and so on. You are literally off to the races running this part and moving on to production. So thank you for being here for the demo. I breezed over a lot of things. If you have any questions at all to get into the nitty-gritty, we'd be happy to do that with you. Let's move back over to the presentation, and we'll finish it out here. All right, so I hope you enjoyed the demo on the RoboJob. There were a lot of cool concepts that we saw on that robot. Before we keep jumping on the last few slides here, I want to talk about the main takeaways about this system. I want to really drive them home. So first and foremost, flexibility. I hope you were able to get that from that product demo just now. So first and foremost, part contact tooling, the grippers. Easily adjust the fingers to accommodate a wide range of diameter of parts. The grid plate table. So I showed you in the software that after you enter your part diameter, graphically, it's going to tell you how to build the stinking table. You don't have to think about anything, which is really cool about that RoboJob. So it's trying to maximize the part density on the table. Got a lot of small parts. You can fit more on the table. You got big parts. Well, you can't fit as many. But the system, the software will walk you through all of that. And third point, the software. The graphical user interface. You follow the recipe structure. Conversational programming I talked about earlier in the presentation there. Truly, you do not need a robot expert on your staff. The software is the secret sauce of that solution. And again, no robot expert needed. I want to drive that point home. As long as you have your robot champion that is willing to learn the software, you'll be successful with your automation. Now, I'm going to breeze through this kind of quick, but this is really special. Not a lot of people have thought about automating a Swiss outside of a bar feeder, and that's about the best way to automate a Swiss, talking about part volumes and the cycle times. A bar feeder with getting stock in, beautiful way to automate a Swiss. The post-processing, though, at IMTS in the Tsugami America booth, there was actually a flavor of automation where we were taking parts off the machine, we were blow drying them, washing them, and laser marking them, not in that order, but we were able to combine these auxiliary processes to reduce the amount of times that an operator may have to touch the part. So I wanted to highlight on this just to make you aware that the solution exists. If you're thinking about, man, I would love to do something with the parts coming off my Swiss machine, clean, dry, inspect, gauge, or laser mark, palletize, you need to tray the parts or you need to bin the parts. Tsugami America and the Precision360 team has solutions available to post-process and automate the parts coming out of a Swiss machine. Here's a quick little diagram of the solution that was actually at IMTS in the Tsugami America booth. Parts were coming off the CNC machine via conveyor, coming down a chute where the parts would sit. Robot would grab the parts off the chute. We would then ultrasonic wash the parts. We would blow them off, get them clean, get all the liquid in the solution off the parts. We would actually laser mark them. This was a medical application. We were showcasing the laser marking in a medical application with this demo part. And then we would tray the parts. So a lot was going on there. And again, I want to make you aware that post-processing in a Swiss application, it's here. And it's very exciting. So if you have a need like that, please reach out. How much does it cost to automate? Man, this could be a whole seminar of itself. So let's talk about the first item here, automation cost versus machine cost. I beg you, please don't try to pit the robot against the machine costs. The automation, it could cost a lot, sometimes as much, if not more, than the CNC machine in some applications. I'm here to tell you that's not the right way to look at automation. Automation is looking to grow your team. It's looking to make that spindle more efficient and maybe freeing up somebody on your team that can be doing higher skilled work while the robot does the tending. So when you think about trying to look at automation costs as a whole, don't try to compare it to the CNC machine. Think about what it's going to do for you on your team and maybe displacing the labor and trying to get more out of your equipment. So another thing that I wanted to also make you aware of, total cost. It's not just about the robot cell. The robot and the installation will be its own package, but if you remember in a few slides ago in the presentation right before the demo, I talked about options. You got to prepare your machine. So I just wanted to make you aware that there's going to be automation costs, but you got to make sure your machine's ready. Auto door, robot interface, mist collection if needed. So just be aware that the machine's going to need to be outfitted as well, and there's some costs associated with that. So how much does it cost to tend your machine now? And I want you to look at that. When you're looking at the people on your team, your labor rates, how much the spindle's churning, those are the kind of questions and discussions that we like to talk with people on to see if automation's right for you. So on automation, we're talking ROI here, your spindle's going to be more efficient. You're going to make more parts at the end of the shift or overnight. When you start working out the napkin math and you see, okay, yeah, if I can make 20 extra parts a day, 50 extra parts a day, whatever that number is for you, okay, yeah, no, if I add that amount of parts per day per month, okay, yeah, I can see the numbers go up. So also looking at the time running. So I'm going to make that spindle more efficient, and then how often is that machine going to be running? So am I capturing the lunchtime hours? Am I capturing breaks, the 15, 20-minute breaks during the day that operators may have, running into a second shift? So we're making the spindle more efficient, and then let's look at how much time, that opportunity time we have to keep the machine running, and we'll keep doing the calculation there to see how many parts we'll get at the end of the day. And then the other thing too that sometimes gets overlooked, okay, great, yeah, I parked the robot in front of the machine. Well, because you parked the robot in front of the machine, you now have a team member on your team that can now go and do maybe a higher skilled work, job setup, changing out tools, tending to other machines. So we're almost giving you labor and you're almost getting some back. So you're almost double dipping there, which is kind of a cool concept that I want to make sure people pay attention to, because you will get time back from your team having automation on your shop floor. So this is the whole mental calculation, that napkin math almost, that we like to walk people with to get them to see, okay, yeah, no, maybe automation is right for me after doing the math like that. Closing thoughts. We talked about so much today. I appreciate your time and attention. First and foremost, automation, it's not this thing that's on the horizon. It's here today. I think you all understand that. You're watching the video or you're here today. on the shop floor. Automation is here, and you got to be thinking about it. Having a plan and understanding how automation might benefit you and on what machines and in what applications, be thinking about that at the very least. Is your machining process ready for automation? I challenge you, please see how many times during the day somebody cannot take the finished part out, load a raw part in, and hit cycle start. You're blowing the part off, you're emptying the chip bin, you're replacing tool inserts, you're making wear offsets. Take notes of all those times, because we're trying to find that home run of a project where if you see the value of automation, a reliable machining process is the foundation for a successful automation project. The third thing here, what are your expectations? That's what I was trying to do here with a lot of topics in the seminar here. I want you to think about what matters to you. What are your expectations for unattended runtime, for how many parts you'd like to set up? How many parts should the robot be able to handle? I can't answer these questions. That's a you decision, but be able to think about what are your expectations of the automation as you embark on your journey looking at solutions. Does a standard automation solution based on lower volumes but quicker setups make sense for your shop? So that's back to the whole high mix, low volume conversation. Standard automation like the RoboJob, if you remember back to earlier slides, you got to be flexible, you got to be able to run a wide range of parts, but the changeover's got to be really quick. So understanding the parts coming in the shop and then trying to pair that with, does that make sense for standard automation? That's the big question there. I want this solution to make sense for you and your shop and understanding what's coming through the door. And last but not least, we'll end with questions. If there's any right now, we'll happily take them. If not, if you're joining us online here, please feel free to reach out to automation@precision360.com, and we'd be happy to answer those for you. Thank you for tuning in, and hope to see you soon.